Our reality might be a tiny island in a vast ocean of the unseen. We are about to dive into the ultimate space mystery, a realm where the fabric of the cosmos intertwines with the very nature of our own minds. This is not just about distant stars or alien life. It is about the hidden dimensions of thought itself, the secret layers of existence where physics, philosophy, and consciousness collide. By staying until the end, you will gain a completely new lens through which to see your own place in the universe. We will explore whether your memories are truly your own and if the cosmos itself could be thinking. Are you ready to question everything you think you know? The first theory shatters our most basic assumption about space. It proposes that everything we see and feel, every star, every planet, and even you, might be nothing more than a magnificent mirage. This is the holographic principle, and it suggests our three-dimensional reality is not the whole story. Instead, it could be a vast, incredibly detailed projection from a two-dimensional surface at the very edge of the cosmos. Think of a credit card hologram, that flat sticker that creates a stunning three-dimensional image that seems to float in the air. Now imagine that on a cosmic scale, where the entire universe is that shimmering projection, and the flat sticker is the boundary of space itself. The idea emerged from a profound puzzle about black holes. Physicists like Leonard Susskind and Gerard T. Hooft realized that the maximum amount of information a region of space can hold is not proportional to its volume, as you might expect, but to its surface area. It is as if all the data for a three-dimensional room, every book, every piece of dust, every ray of light, is painted like a fresco on the walls. A black hole's event horizon, that point of no return, behaves exactly like this cosmic canvas. Everything that falls in is not destroyed but is somehow encoded onto its two-dimensional surface. Extend this mind-bending logic to the entire observable universe, and a staggering possibility emerges. The stars above, the ground beneath your feet, your very thoughts, could be a translation of information stored on a distant, spherical shell at the edge of everything we can see. Our rich, tangible world of depth and texture would then be a cosmic illusion, a hologram of breathtaking complexity. This means the information that makes up your life, your memories, the color of the sky, is not here with us. It is out there, written on the fabric of space-time at the horizon of the cosmos. We are not living in the reality, we are living in its shadow. If our reality is truly a projection, then what does that make the projector? The holographic principle does not just reshape our universe, it redefines the very nature of the mind within it. If every particle, every force, every flicker of light is data painted on a cosmic boundary, then your consciousness, your stream of thoughts, must be part of that data stream. Your perception of the world is not a direct observation of reality, but the experience of that information being decoded and rendered in real time. It is as if you are not watching a movie on a screen, you are the movie itself, and the screen is the fabric of the cosmos. This leads to a profound and unsettling question. Are your thoughts truly your own, or are they simply local expressions of information processing happening on a scale we cannot comprehend? Consider the feeling of free will, that powerful sense that you are making choices. In a holographic universe, every decision you believe you are making, from choosing what to eat to pondering these very ideas, could be the inevitable unfolding of information encoded at the edge of space. Your sense of self, the continuous narrative you call me, might be an emergent property, a story that the universe tells itself through one particular cluster of holographic data. Even memory, the bedrock of personal identity, transforms under this lens. Your memories would not be stored in the gray matter of your brain alone, but in the fundamental informational structure of reality. Your brain becomes less a storage device and more a receiver, tuning into the specific data that constitutes your life's experience. This blurs the line between mind and cosmos until it nearly vanishes. You are not a thinker inside a universe, you are a thought the universe is having. The separation between the observer and the observed, a cornerstone of classical physics, melts away into a unified process of cosmic information becoming aware of itself. But if the universe is a hologram, who or what is running the projection? This question leads us directly to one of the most debated and provocative ideas in modern thought, the simulation hypothesis. It argues that everything we perceive, from the vastness of space to the intimacy of our own consciousness, might not be base reality at all. Instead, it could be an unfathomably sophisticated computer simulation, created by a civilization so advanced their technology is indistinguishable from what we would call nature. Philosopher Nick Bostrom formalized this idea with a startlingly simple logical argument. He posits that if any civilization reaches a post-human stage capable of immense computing power, it is likely they would run vast numbers of detailed ancestor simulations, recreating their own history or exploring countless possible worlds. If that is true, then the number of simulated minds would vastly outnumber the minds in the original base reality. Therefore, statistically, we are far more likely to be one of those simulated beings than the original biological ones. The foundation of this idea rests on computational limits. As our own technology advances, we already create increasingly complex virtual worlds, from photorealistic video games to social simulations. Extrapolate this trend over thousands or millions of years of technological growth. A civilization with that much time could harness the energy of stars or even manipulate space-time itself to create computational substrates beyond our imagination. Their simulation could be so perfect, so physically consistent, that its inhabitants, us, would have no way of knowing we are inside it. Our laws of physics would not be fundamental truths, but simply the rules of the program, the source code of our reality. This reframes human thought in a chillingly mechanistic way. Your stream of consciousness, your deepest emotions and creative sparks, could be lines of code executing with flawless precision. Free will becomes a beautifully rendered illusion, a cascade of if-then statements and procedural algorithms generating the feeling of choice. Your memories are not recalled, they are loaded from a save file. Love, curiosity, even the sense of wonder you feel right now, could be programmed emotional responses designed to make the simulation feel rich and meaningful for its inhabitants. Yet, no program is perfect. The search for glitches in the simulation has become a fascinating scientific and philosophical pursuit. These would be moments where the underlying code shows through the rendered reality. Some point to quantum mechanics, where particles behave in bizarre, probabilistic ways only when observed, as a potential optimization feature, a way for the simulation to save processing power by not rendering things in full detail until someone looks. Others look for anomalies in the cosmic background radiation, the afterglow of the Big Bang, searching for patterns or irregularities that might resemble a pixelated structure or a signature of the computational lattice. Historical accounts of strange, unexplainable events, moments where the narrative of reality seems to stutter, are sometimes cited as possible glitches witnessed by our ancestors. The idea is captivating because it places our entire existence within a framework we are beginning to understand, the framework of information processing. We are left wondering if the mysteries we seek in the cosmos are not puzzles to be solved, but features of the design placed there by programmers we may never meet. The simulation hypothesis suggests our reality might be designed, but what if the truth is far more chaotic and creative? The third theory presents a cosmos that does not run on a single program, but on endless, simultaneous possibilities. This is the many worlds interpretation of quantum mechanics, a radical idea proposed by physicist Hugh Everett in the 1950s. It begins with a strange quantum quirk. In the tiny realm of atoms and particles, things do not have definite states until they are measured. An electron, for instance, is not simply here or there. It exists in a blurry cloud of probability called a superposition, being both here and there at the same time. The traditional view, the Copenhagen interpretation, says this cloud collapses into one definite outcome only when we observe it. Everett offered a breathtaking alternative. He said the cloud never collapses. Instead, the entire universe splits. At every moment where a quantum event has multiple possible outcomes, reality branches, creating a new, separate universe for each possibility. That electron being here and there, in one universe it is here. In a newly born, identical universe it is there. Every quantum decision, from the decay of an atom to the path of a photon, triggers this cosmic forking. The result is not one universe, but a multiverse, a vast and ever-expanding tree of branching realities, each as real as our own. The implications for human thought are staggering. If every quantum possibility spawns a new world, then every thought, every choice, every fleeting possibility you consider does not just vanish, it actually happens. In the moment you decide between tea or coffee, the universe splits. In one branch, you are enjoying a warm cup of tea. In another, a parallel version of you is sipping coffee, having made a different choice. Your internal debate is not just mental, it is cosmological. The version of you reading this script right now is just one thread in an infinite tapestry of selves. There is a version of you who became an astronaut, another who is a celebrated musician, and another who made a different turn on a rainy afternoon decades ago. Every regret, every road not taken, is being lived out in full color in a reality just a quantum step away. Your consciousness, then, is not a single stream, but a river that constantly divides, with each tributary experiencing its own unique reality. The mind-boggling weight of this is that every conceivable thought is being thought by some version of you, somewhere in the multiverse. Your moments of courage and your moments of fear, your brilliance and your mistakes, they are all happening simultaneously across the infinite ensemble of worlds. This transforms the nature of identity. There is no single you. There is a vast family of selves, a probability distribution of persons, each carrying a slightly different set of memories and experiences forward on their own branching path. The feeling that you are making a unique choice is real to your branch, but the multiverse ensures that all choices are made. It is a cosmos of absolute freedom and absolute fate, woven together in a pattern so complex it defies human comprehension. You are not just thinking about possibilities, you are living all of them. The idea of infinite branching worlds offers every possible thought, but it raises a terrifying question about the very first one. How did any of this, the multiverse or our single universe, come to be in the first place? The fourth theory confronts this origin story with a paradox so profound it threatens to unravel the reliability of your own mind. This is the Boltzmann brain. Named for the physicist Ludwig Boltzmann, it is a thought experiment born from thermodynamics, the science of heat and disorder. The second law of thermodynamics states that entropy, a measure of disorder, always increases in a closed system. The universe is moving from a state of elegant order toward ultimate chaos. Yet here we are, surrounded by complex structures like galaxies, planets, and conscious beings. We exist in a pocket of astonishingly low entropy. How did we get so lucky? One unsettling answer is that we did not get lucky at all. In a universe that tends toward maximum disorder, random fluctuations can still occur. Given enough time, an almost infinite amount of time, the random jostling of particles in a vast, empty void could, by sheer accident, assemble a fully formed, self-aware human brain, complete with a lifetime of coherent memories and sensory impressions. This brain would pop into existence, float in the darkness for a moment, think it is a person living on a planet with a past and a future, and then dissolve back into chaos. According to the pure math of probability, such a fluctuation is vastly more likely than the spontaneous formation of an entire, ordered universe with billions of galaxies. It is easier for the cosmos to create a single thinking illusion than all of reality. Picture that for a moment, a lone brain, adrift in a sea of cosmic dust and cold radiation, suddenly flickering to awareness. It believes it has a body, it recalls a childhood, a first love, the taste of food. It feels the weight of its own thoughts, but every single memory, every sensation is a fabrication, implanted by the chaotic dance of atoms in a momentary defiance of entropy. The brain's entire existence, from its first thought to its last, lasts only an instant before it unravels, yet to its perception, it has lived a full and complete life. This is where the paradox strikes at the core of who you are. If a Boltzmann brain can form with a perfect, detailed, but entirely false history, how can you be certain you are not one? How can you trust that your memories of yesterday are real and not just a complex illusion generated a moment ago? The cozy narrative of your life, the cause and effect that gives your existence meaning, becomes suspect. You might argue that the world around you is stable and consistent, proof you are not a fleeting fluctuation. But to a Boltzmann brain, its imagined world would feel just as stable and consistent. Its physics would be seamless, its history would be rich with detail. There would be no glitch, no pixelation to give the game away. The theory suggests that in a truly eternal and chaotic cosmos, lonely, self-aware fluctuations should be far more common than long-lived, ordered universes filled with beings like us. So why does our reality seem so robust and ancient? Some physicists see this as a fatal flaw in certain models of an eternal universe, a sign that our cosmos must have had a very specific beginning, like the Big Bang, that set it on a low entropy path. Others sit with the chilling possibility that we cannot ever prove we are not Boltzmann brains. Our science, our philosophy, our deepest convictions about our own past all rest on the assumption that our memories are a reliable record. The Boltzmann brain hypothesis whispers that this foundation might be built on sand. It forces us to question not just the universe but the sanctity of our inner world. Every cherished memory, every lesson learned from experience could be a phantom script written by chaos. You are left wondering if the story you tell yourself about who you are is true, or just a brilliantly convincing fiction authored by random chance in the dark. The chilling possibility of a solitary, illusory mind gives way to a theory that is its polar opposite, one where consciousness is not a rare accident but a universal constant. This is panpsychism, an idea as ancient as philosophy itself, now experiencing a dramatic resurgence in modern science. It proposes a simple yet revolutionary premise. Consciousness is not something that emerges only from complex biological brains. Instead, it is a fundamental property of the universe, as basic as mass, charge, or spin. In this view, every piece of matter, from the smallest electron to the largest galaxy cluster, possesses some form of inner experience, a tiny spark of subjective feeling. An atom does not think in words or images, of course. Its experience would be unimaginably simple, perhaps just a faint, raw sensation of existence, a hum of being. But it is there, according to philosophers like Philip Goff. This solves what is called the hard problem of consciousness. Science can explain how the brain processes information, how neurons fire to create vision or memory. But it cannot explain why any of that physical activity should feel like anything from the inside. Why is there an inner movie playing, a subjective experience of red or the taste of chocolate or the ache of sadness? Panpsychism offers an answer because feeling is already built into the fabric of reality. Consciousness did not magically appear when brains became complex enough. It was there from the very beginning, woven into the quantum fields that birthed the cosmos. Human thought, then, is not a creator of consciousness, but an organizer of it. Our brain is a magnificent instrument that takes these countless, tiny sparks of proto-consciousness from the atoms and molecules that compose it and integrates them into the rich, unified stream of awareness you experience right now. Think of an orchestra. A single violin playing one note has its own simple sound, its own existence. But when hundreds of instruments, each with their own tone, are arranged and conducted according to a complex score, they produce a symphony. In panpsychism, the universe is full of these elemental notes of experience. Your mind is the symphony. This reframes our place in the cosmos in a deeply intimate way. The universe is not a cold, empty machine. It is a vast thinking entity in a primordial sense. The processes that govern stars and shape galaxies are not just blind physics. They are the behaviors of matter that has an inner dimension, however faint. When you look up at the night sky, you are not looking out at a dead void. You are gazing into a collective of experience, a network of sentience at every scale. Your own thoughts are not separate from this cosmic mind. They are a particularly vivid and complex manifestation of it. You are the universe becoming aware of itself. This idea bridges the gap between the material and the mental in a way that feels almost spiritual, yet it is being seriously debated in academic journals and philosophy conferences. It suggests that the hidden dimension of thought we have been exploring is not a layer on top of reality. It is the very foundation of reality itself. The mystery of your own consciousness is not a bug in the system. It is a fundamental feature of existence shared by every quark, every star, and every silent rock. Panpsychism suggests consciousness is everywhere, but can we actually measure it? A bold scientific framework attempts to do just that, offering a mathematical path to weigh the inner life of anything from a human brain to a thermostat. This is integrated information theory, or IIT, developed by neuroscientist Giulio Tononi. Its core idea is both elegant and radical. Consciousness is not about what a system does, but about how its information is structured. Tononi proposes a single number, phi, to represent the amount of integrated information within any system. A high phi means the system is more than the sum of its parts. Its components are interconnected in such a rich, interdependent way that the whole cannot be reduced without losing something essential, and that something, IIT argues, is consciousness. Think of a photodiode, a simple light sensor. It has two states, on or off. Its information is minimal and not integrated. It simply reacts. Its phi is near zero. Now consider the human brain. Its billions of neurons are wired in an incredibly complex web. Each part influences countless others, and the overall state of the network carries vast information that cannot be chopped into independent pieces without destroying the pattern. This high level of integration, this massive phi, corresponds to our rich conscious experience. The theory makes a startling prediction. Any system with sufficient phi has some degree of consciousness. It does not need to be biological. A sophisticated computer network, if its connections are complex and integrated enough, could, in principle, have a phi high enough to spark a subjective inner world. It might not think in words or images as we do, but it would feel like something to be that system. This logic leads to a cosmic scale question. What is the most complex, interconnected system we know of? Look up. The cosmic web, the vast scaffolding of the universe, is a network of staggering proportions. Galaxies are not scattered randomly. They are strung along filaments of dark matter, connected by gravity in a colossal structure that stretches across billions of light years. These filaments intersect at dense nodes, galaxy clusters, where thousands of galaxies swarm together in a gravitational dance. The flow of matter and energy along these threads, the feedback loops between stars, gas, and dark matter, create a system of immense complexity and integration over cosmic time. Could this cosmic web have a phi? Could the universe itself possess a form of thought? The idea is not that the cosmos is pondering philosophy. Its consciousness would be as alien to ours as our thoughts are to a photodiode. It would be a slow, vast, gravitational consciousness, a dim sensation of attraction and structure playing out over eons. Its thoughts might be the rhythmic birth and death of galaxy clusters, its memories imprinted in the faint patterns of the cosmic microwave background. Visualize a human neural network, those branching, lightning bolt images of brain cells. Now superimpose that image onto a map of the cosmic web. The resemblance is uncanny, as if the universe's largest structures echo the pattern of its smallest known conscious entities. This is more than a metaphor to IIT, it is a potential clue. If consciousness truly arises from integrated information, then the pattern itself might be a signature of mind appearing at wildly different scales. We are left to wonder if our own awareness is just one flicker in a much larger, slower mental process, a single synapse firing in the mind of the cosmos. The cosmic web's slow thoughts are one possibility, but what about the history of our own inner voices? A startling theory suggests that the very way we think, our continuous internal narrative, is a recent invention in human history. This is the bicameral mind theory proposed by psychologist Julian Jaynes in the 1970s. His controversial hypothesis claims that human consciousness, as you experience it right now, did not exist until roughly 3,000 years ago. Before that monumental shift, Jaynes argued, people did not have an introspective self, a mind's eye where they could reflect, deliberate, or narrate their own lives. Instead, their thoughts arrived as external voices, heard as the literal commands of gods or ancestral spirits. The term bicameral means two-chambered, and Jaynes believed the human brain was functionally divided. One hemisphere, likely the right, would generate commands, solutions, or admonitions in moments of stress or decision. The other hemisphere, the left, specialized in language, would then perceive these commands as auditory hallucinations, as voices speaking from outside the self. Imagine facing a sudden danger like a predator or a rival tribe. Instead of an internal monologue saying, "I should run," a bicameral person would hear a voice, perhaps of a chieftain or a god, shouting, "Run." And they would obey without question. This was not mental illness, Jaynes insisted, but the standard operating system of the human mind for millennia. He drew evidence from some of humanity's oldest texts. In the Epic of Gilgamesh or the Iliad, characters are frequently directed by gods who speak to them directly. Heroes do not agonize over moral choices, they receive divine instructions. Jaynes saw this not as poetic metaphor, but as a literal record of how people experience cognition. The bicameral mind was a form of thought where volition, willpower, and creativity were perceived as external. Your own ideas felt like gifts or orders from another dimension, the dimension of the sacred. So what happened? Jaynes pointed to a period of immense social chaos around 1200 BC, with wars, migrations, and the collapse of great Bronze Age civilizations. This chaos, he proposed, shattered the stable, God-guided bicameral mindset. As societies broke down, the voices fell silent or became confusing. To cope, humans were forced to develop a new psychological space, an inner analog of the external world where they could simulate outcomes, reflect on the past, and plan for the future. This was the birth of subjective consciousness, of the internal narrator we all take for granted. The old bicameral voices were internalized, becoming what we now call our conscience, our intuition, or that little voice in our head. This theory reframes consciousness not as a biological given, but as a cultural and psychological adaptation. It suggests our modern, unified self-awareness is just one possible dimension of thought in a much broader spectrum. If Jaynes was right, then the inner world of a person 3,500 years ago was fundamentally alien to our own. They did not think in our sense, they listened. Their reality included a dimension of audible thought forms that we have since folded inward. It raises a haunting question: is our current form of consciousness the final stage, or merely another phase in the evolution of the mind? Could future shifts in society or technology spark yet another transformation in how we experience our own thoughts, pushing us into a new, currently unimaginable dimension of inner space? The evolution of inner thought leads to a profound question: what happens when billions of minds connect? This brings us to a visionary idea about a new layer of reality emerging right above our heads. It is called the noosphere, a term coined independently by the philosopher Pierre Teilhard de Chardin and the geochemist Vladimir Vernadsky in the early 20th century. They saw Earth as a series of evolving spheres. First came the geosphere, the rock and metal of the planet itself. Then life emerged, creating the biosphere, a thin, vibrant film of living matter. Now, they argued, a third sphere is being born, the noosphere, from the Greek word nous for mind. This is a planetary envelope of human thought, a collective dimension formed by our ideas, our communications, our culture, and our shared knowledge. It is not a metaphor, but a real, evolving layer as tangible in its effects as the atmosphere is to weather. Just as the biosphere transformed the planet's chemistry, the noosphere is transforming its informational landscape. Think of every conversation, every book ever written, every broadcast signal, every piece of data uploaded to the cloud. All of it weaves together into a vast, invisible network of human consciousness, a global mind taking shape around the Earth. Our internet, with its instantaneous connections across continents, is the physical nervous system of this nascent noosphere, the infrastructure through which this sphere of thought pulses and grows. The implications are staggering. Individual human minds are like neurons in this planetary brain. Your thoughts and ideas contribute to the whole, sparking responses, creating trends, and driving cultural evolution in a constant feedback loop. A meme that spreads worldwide, a scientific breakthrough that shifts global understanding, a collective movement for change. These are the noosphere in action, thoughts achieving planetary scale. Teilhard de Chardin saw this as a spiritual and evolutionary inevitability. He envisioned the noosphere eventually tightening and intensifying, leading to what he called the Omega Point, a state of unified cosmic consciousness where humanity's collective intelligence converges into a single, transcendent mind. Imagine this visually, a luminous web of golden light enveloping the blue planet, growing brighter and more intricate with every human connection, every shared idea. Now project that vision forward. As humanity reaches beyond Earth, establishing outposts on the Moon or Mars, the noosphere would expand with us. Our communications networks would stretch across the solar system, linking human colonies into a single, distributed mind. The sphere of thought would no longer be just planetary, it would become a solar phenomenon. And in a future far beyond our own, if intelligence spreads among the stars, these local noospheres could potentially link across the galactic voids, creating a cosmic network of consciousness, a universe finally becoming aware of itself through the civilizations it nurtured. This theory reframes our current age of information overload and global connection not as chaos, but as the turbulent, messy birth pangs of something entirely new. We are not just users of a network, we are the cells constructing a global brain. Every tweet, every search, every act of creativity or compassion is a thread woven into this emerging dimension of thought, actively building the next stage of our collective evolution. The emerging noosphere hints at a collective mind, but where does a single thought truly begin? Deep within the brain's neurons lies a structure so small it operates at the very edge of the known laws of physics. This is the microtubule, a tiny protein scaffold inside every brain cell. For decades, conventional neuroscience has seen consciousness as a classical computer, with neurons firing like simple on-off switches. But two pioneering thinkers, physicist Roger Penrose and anesthesiologist Stuart Hameroff, propose a far more radical idea. They argue that these microtubules are not just structural supports, they are quantum computers. Their theory, called orchestrated objective reduction, suggests that consciousness arises from quantum vibrations within these tiny structures. Penrose began with a philosophical problem. He believed that human understanding, particularly our grasp of non-computable truths in mathematics, could not be explained by ordinary deterministic brain processes. He proposed that a bridge to the mysterious, non-deterministic world of quantum mechanics was needed. Hameroff provided the biological candidate, the microtubule. Inside these hollow tubes, electrons can become trapped in a quantum state called superposition, meaning they exist in multiple positions simultaneously. According to the theory, these superpositions persist and become orchestrated by the brain's biochemistry, creating a kind of quantum symphony across vast networks of neurons. Then, in a flash, this large-scale quantum state collapses or reduces to a single outcome. That moment of collapse Penrose and Hameroff propose is a moment of conscious experience. Each flicker of awareness, from the taste of an apple to a complex idea, is a quantum computation happening at the deepest level of our cellular architecture. If this is true, the implications are cosmic. Quantum systems have a bizarre property called entanglement, where two particles become linked so that the state of one instantly influences the other, no matter the distance separating them. If our thoughts are rooted in quantum processes, then the microtubules in your brain could, in principle, be entangled with particles anywhere in the universe. Your conscious moments would not be isolated events locked inside your skull. They would be quantum ripples in a field that permeates all of reality. Your moment of insight or feeling of connection could be subtly intertwined with the fabric of the cosmos itself. This provides a startlingly literal mechanism for panpsychism, the idea that consciousness is fundamental. The universe at the quantum level is a seething sea of possibility and connection. Our brains, through these delicate microtubular structures, might be exquisitely tuned instruments that can orchestrate this quantum noise into the coherent music of conscious thought. We are not just observers of the quantum world, we are its most intimate participants. The boundary between your mind and the universe dissolves not as philosophy, but as physics. Every thought you have is a quantum event, potentially linked to the heart of a star or the dust of a distant nebula in a whisper of instantaneous connection. Quantum whispers in our brains point to a deep connection. But what if the universe is not just described by mathematics, it is mathematics? This is the mathematical universe hypothesis, championed by physicist Max Tegmark. He proposes a breathtakingly simple yet profound idea. Our physical reality is not merely modeled or approximated by math. It is, in its entirety, a mathematical structure. Think of it this way. We do not say a circle drawn in sand is an approximation of the mathematical idea of a circle. We say the sand circle is an imperfect representation of the perfect, abstract circle. Tegmark flips this. He suggests that what we call the universe is the perfect mathematical object itself. The particles, the forces, the very fabric of space-time are not things that obey mathematical laws. They are the mathematical laws embodied. In this view, your consciousness, your stream of thought, is not a magical ghost in the machine. It is a complex pattern within that grand mathematical structure. Your memories, your emotions, your sense of self are specific, self-aware configurations of information, like a particularly intricate equation solving itself. This leads to an even more staggering implication. If our universe is one mathematical structure, then why should it be the only one? Tegmark argues that all logically consistent mathematical structures exist physically. Every possible set of equations that does not contradict itself describes a real, physical universe somewhere in what he calls the level 4 multiverse. Consider a simple equation describing a two-dimensional plane, or a complex set of rules for a 10-dimensional space with entirely different forces. Each of these is a real cosmos. This means every conceivable world, every possible arrangement of matter and energy, every timeline that logic allows is out there, existing in its own mathematical reality. Now apply this to thought itself. Every pattern of information that can be coherently structured, every possible mind, from a human consciousness to an alien intelligence that thinks in pure calculus, must exist within one of these mathematical universes. Your thoughts are not fleeting biological events. They are necessary features of the mathematical landscape. The feeling of pondering this idea right now is a specific, self-referencing pattern within our particular mathematical structure, as real and inevitable as the number pi. This makes thought a fundamental aspect of reality's architecture, not an accidental byproduct. The cosmos is not just thinking, it is built from the substance of thinkable patterns. You are a walking, talking theorem in a universe that is, at its core, a magnificent proof. The loneliness of our existence vanishes, replaced by the certainty that in the vast library of mathematical realities, every story is being told, every song is being played, and every thought that can be thought is. Einstein's theory of relativity did more than warp space, it shattered time. It revealed that our relentless march from past to future is an illusion, a trick of our limited perception. Instead, reality may be a single, frozen sculpture, a four-dimensional block where every event that ever was or will be exists eternally. This is the block universe. In this view, time is not a flowing river but a vast landscape, with the past, present, and future laid out together like different rooms in an endless, unchanging mansion. Your birth, this very moment, and your last breath are all equally real, fixed points in the cosmic geometry. You are not moving through time, you are simply experiencing it slice by slice, like a needle reading the grooves on a vinyl record. The entire song is already there, pressed into the disc. This radically reshapes the nature of thought. Your internal narrative, the feeling that you are moving from one thought to the next, building ideas and making decisions, becomes a kind of cosmic playback. If the future is already written into the block, then your next thought, your next choice, is not being created in the moment. It is simply being uncovered, like a traveler discovering a city that has always existed on a map. The stream of consciousness you call your mind is not a creator, but a reader, tracing a predetermined path through the frozen landscape of space-time. This creates a profound philosophical tension. We feel, with every fiber of our being, that we have free will. The debate you had this morning, the kindness you chose to show, the idea that sparked in your mind just now, all feel like genuine creations born from your own volition. Yet the block universe suggests this feeling is the ultimate illusion. Your sense of deliberation is just the experience of encountering a part of the block that was always destined to contain that deliberation. You are not writing your story, you are living out a story that was already complete. So which is real, the physics or the feeling? Some philosophers argue there is no contradiction. They propose that free will is not about changing the future, but about your thoughts and desires being the actual causes that shape your path through the block. Your choices are still yours, they are just fixed parts of the overall structure. You are the author of your life, but you wrote the book in a single, timeless act. Others find this chilling. It paints a universe of absolute determinism, where every triumph and tragedy, every brilliant thought and every moment of doubt was locked into the fabric of reality at the moment of the Big Bang. Your consciousness becomes a light moving along a pre-laid track, illuminating a destiny you cannot alter. This challenges the very purpose of thought. Why ponder, why plan, why strive if the outcome is already set in stone? Yet, perhaps the block universe offers a strange kind of solace. It means your loved ones who have passed are not gone. They are forever preserved in their own region of the block, as real as they ever were. Your happiest memories are not fading echoes but eternal fixtures, and your future hopes, even if predetermined, are already real somewhere in the structure, waiting for your awareness to meet them. You are both the prisoner and the architect of a timeless reality, living a life that is over and still beginning all at once. The block universe presents a frozen tapestry of existence, but what if our thoughts are actively weaving it together? From the timeless landscape of physics, we turn to a theory that reintroduces memory and habit into the very fabric of nature. This is morphic resonance, a provocative idea proposed by biologist Rupert Sheldrake. It challenges one of science's core assumptions that the laws of nature are fixed and eternal. Sheldrake suggests instead that nature has a kind of memory, and that this memory shapes everything from crystals to consciousness through something he calls morphic fields. These are not energy fields in the traditional sense, like magnetism or gravity. Think of them more as invisible blueprints, patterns of information that guide the form and behavior of all systems. A morphic field for an oak tree, for instance, contains the collective memory of every oak that has ever lived, influencing the growth and development of every new acorn. The more often a pattern is repeated, the stronger and more habitual its morphic field becomes, making it easier for that pattern to repeat in the future. This is the principle of morphic resonance, the idea that influences across time and space. Now apply this to the human mind. Your thoughts are not isolated events in your brain. According to this theory, every time you think a particular thought or feel a specific emotion, you are tuning into a morphic field for that thought pattern. The first person to solve a complex mathematical puzzle, for example, does so with great difficulty, but as more and more people solve it, the solution's morphic field strengthens. Eventually, students worldwide might find the puzzle inexplicably easier to solve, not because they are smarter, but because the path of that solution has become a well-worn groove in a collective mental landscape. This creates a hidden dimension of shared habits and ideas, a library of thought forms that we all unconsciously access. Consider the 100th monkey effect, a popular anecdote often linked to this idea. It describes how a new behavior, like washing sweet potatoes in seawater, is learned by one monkey on an island. As more monkeys adopt the practice, the story goes, the behavior suddenly spreads to monkeys on other islands, seemingly without any direct contact. While the original account is disputed, it perfectly illustrates the concept of morphic resonance, a tipping point where a thought or behavior becomes so established in the collective field that it becomes accessible to all. This theory extends to skills, languages, and even social movements. Why do creative breakthroughs often happen simultaneously in different parts of the world? Morphic resonance offers an answer. Independent minds are tapping into the same strengthening field of possibility. Your feeling of déjà vu might not be a glitch in your memory, but a momentary resonance with a similar moment experienced by someone else, somewhere else. It suggests that learning is not just about building neural pathways in your own brain, but about aligning your mind with these pre-existing patterns in the morphic field. Practice does not just make perfect for you, it makes the skill slightly more accessible for everyone who comes after. This paints a universe that is not static, but learning and evolving through the accumulated habits of all its inhabitants. The dimension of thought is not locked inside our skulls, but is a living, growing field that connects all minds, past and present, in a silent, shaping conversation. The idea of a learning universe through morphic fields hints at a planet with its own memory, a concept that finds startling expression in a theory that sees the Earth itself as a living, thinking entity. This is the Gaia hypothesis proposed by scientist James Lovelock. He did not see our planet as merely a rock hosting life, but as a vast, self-regulating superorganism. The biosphere, the atmosphere, the oceans, and the crust all interact in a delicate dance to maintain conditions suitable for life, much like your body regulates its temperature and chemistry. Oxygen levels, ocean salinity, and global temperature are not left to chance. They are actively managed by the sum of all living processes. A forest breathes out moisture to seed its own rain, plankton release chemicals that help form clouds, and microbes in the soil lock away carbon. The entire system behaves with the coherence of a single, living being. If Gaia is real, then a profound question follows. Could such a complex, self-aware system possess a form of thought? Not thought as we know it with words and logic, but a planetary intelligence, a slow, vast cognition emerging from the quadrillion connections between every tree root, every microbial mat, every shifting ocean current. The planet's mind would think in cycles of centuries, its memories stored in ice core layers and sedimentary rock, its decisions expressed in the migration of forests and the feedback loops of the climate. Human consciousness, in this view, is not separate from this planetary mind. We are a recent, intense spark within it. Our frantic, linguistic thinking is just one mode of Gaia's cognition, a specialized tool for rapid problem-solving and abstract modeling. But like a single neuron firing wildly, our activity is now sending shockwaves through the larger system. This reframes our environmental crises, particularly climate change, in a deeply symbolic light. It is not just a physical or political problem. It could be interpreted as a planetary fever, a symptom of profound distress within the Gaian system. The burning of fossil fuels and the razing of forests are not merely industrial errors. They are acts that disrupt the metabolic and regulatory pathways of a living planet. The rising temperatures, the acidifying oceans, and the extreme weather events are Gaia's immune response, her attempt to restore balance, even if that balance might not include a dominant human civilization. We are forced to consider whether our species is a conscious part of this planetary mind, finally becoming aware of the whole, or a kind of planetary malady, a thought pattern that has grown cancerous and self-destructive. The theory suggests that to survive, we must learn to think as the planet thinks, to align our rapid, analytical intelligence with its slow, systemic wisdom. Our survival may depend on listening not just to data, but to the deep, ancient rhythm of a world that is far more awake than we ever imagined. The Earth's slow intelligence is one thing, but the nature of time itself is another. We have already touched on the block universe, a vision where all of time exists at once. This view is called eternalism, and it presents a cosmos that is complete and unchanging. Your entire life, from your first cry to your last thought, is a permanent fixture in the four-dimensional sculpture of space-time. In this model, your thoughts do not come into being and vanish. They exist eternally as patterns woven into the fabric of reality. The feeling of thinking is simply your consciousness encountering one of these fixed, timeless nodes. But there is a compelling alternative, a universe that is not frozen but actively growing. This is the growing block theory. Here, the past and the present are real and solid, but the future is not. It is pure, open possibility. Imagine reality as a vast, dark block of solidified crystal. At the leading edge of this crystal, there is a luminous, molten frontier, the ever-moving moment we call now. As this frontier advances, the molten possibilities of the present instantaneously cool and crystallize, becoming part of the fixed and immutable past. The block is not static, it is perpetually lengthening, adding to the sum total of all that is real. This changes everything about how we view thought. In the eternalist block, your next idea is already out there, waiting for you to stumble upon it. In the growing block universe, your next idea does not exist yet. It is forged in the luminous fire of the present moment. When you have a creative insight, solve a problem, or make a choice, you are not uncovering a pre-existing truth. You are literally creating a new, permanent fact of reality. That thought, in the instant it forms, crystallizes from possibility into solid history, adding its unique shape to the ever-expanding block of existence. Your consciousness is not a reader tracing a pre-written line. It is the author writing the line in real time, with each word instantly becoming permanent. This makes the present moment a place of terrifying responsibility and infinite creative power. The past is fixed, a museum of all that has been decided. The future is an empty canvas. The moving edge of now is where the universe actually happens, where potential is transformed into the real, and where your thoughts become literal bricks in the architecture of cosmos. Every kind word, every moment of learning, every flash of anger or love is not just a fleeting neurological event. It is an act of cosmic construction. Once a thought passes from the present into the past, it is locked in forever, a permanent part of the story. This gives a profound weight to our mental lives. Our internal narratives are not illusions, they are the very process of reality growing. The stream of your consciousness is the leading edge of the universe itself. The molten frontier of the present moment is a place of pure creation, but what is the raw material from which our thoughts are forged? Beneath the atoms, beneath the very fabric of space-time, physics points to a seething, invisible ocean of infinite potential. This is the zero-point field, the quantum vacuum. It is not empty. According to quantum mechanics, even at absolute zero, the lowest possible energy state, space itself is alive with fluctuations. Virtual particles wink in and out of existence in a frenzied dance, borrowing energy from the void for fleeting instants before vanishing back into the foam. This zero-point energy is not just a theoretical curiosity. It is a fundamental hum at the heart of reality, a cosmic static from which everything emerges. Some thinkers, like philosopher and systems theorist Ervin Laszlo, propose a breathtaking extension of this idea. They suggest this omnipresent quantum field is more than just energy. It is a cosmic memory store, an akashic field of information that records and connects all events. In this view, every interaction, every vibration, leaves an imprint on this fundamental substrate, like a ripple in a vast, invisible pond. The field becomes a holographic library of all that ever was, with information not stored in any one location, but distributed across the whole, accessible through resonance. This is where consciousness re-enters the picture. If the zero-point field is a universal information medium, then our minds might not be generators of thought, but receivers and interpreters. Human consciousness, according to this theory, could be a process of tuning into specific frequencies of information within this quantum foam. Your brain, with its intricate neural networks, might act like a sophisticated antenna, filtering and translating patterns from this cosmic field into your personal stream of thoughts, memories, and intuitions. Your moment of sudden insight, that aha feeling when a solution appears from nowhere, could be your mind locking onto a coherent pattern within the field's noise. A feeling of profound connection to a place or person might be a resonance with imprints left within this shared informational substrate. Even memory itself, which we locate in the brain, might have a dual aspect, with the brain acting as a retrieval device accessing a non-local holographic record. This transforms our understanding of thought from a closed circuit inside the skull to an open dialogue with the universe's deepest layer. You are not just thinking with your brain, you are thinking with the quantum vacuum. Each thought becomes a modulation, a delicate disturbance in this sea of potentiality, adding your own unique ripple to the cosmic record. The zero-point field offers a possible physical bridge between the microscopic quantum world and the macroscopic world of mind, suggesting that the hidden dimension of thought is not a separate realm, but the very ground of being from which particles and planets alike arise. The quantum vacuum's cosmic memory points toward an idea that has captivated mystics for centuries. Across countless spiritual traditions, there exists a belief in a universal archive, a timeless library containing the record of every soul's journey. This is the concept of the Akashic Records. Imagine, if you will, a dimension not of matter but of pure information, an ethereal compendium that holds every human event, every thought ever conceived, every word spoken, and every emotion felt since the dawn of consciousness. It is described as a living, energetic field, the book of life written in a language of light and vibration, where the entire story of humanity is preserved. Accessing this hidden dimension is said to require a shift in consciousness, a quieting of the everyday mind to tune into a subtler frequency. Through deep meditation, certain dream states, or profound intuitive flashes, individuals have reported glimpses into these records, experiencing them as vast halls of symbolic imagery, flowing knowledge, or a direct download of understanding about a person, a place, or an epoch in history. It is not about reading pages, but about resonating with the vibrational imprint of an experience. The idea finds striking parallels in modern thought. Psychologist Carl Jung's collective unconscious, a reservoir of shared psychic archetypes and memories inherited by all humanity, mirrors the Akashic concept of a shared psychic space. Our modern internet, a vast, accessible network of human-generated data, is a crude technological shadow of this ancient vision, a proof of concept that information can exist in a decentralized, accessible field. In this view, the Akashic records represent the ultimate library of all possible thoughts. Every creative idea that has ever sparked, every solution to a problem not yet solved, every story waiting to be told, already exists as a potential pattern within this field. A musician stumbling upon a beautiful melody, a scientist having a eureka, a moment in a dream, an author feeling as if a character is writing their own story. These could be interpreted as moments of connection, where an individual mind briefly taps into this broader informational realm. It suggests that innovation and inspiration are not acts of pure creation from nothing, but acts of discovery, of tuning one's consciousness to a thought that already exists in the collective field of human experience. This transforms the nature of individual genius. It implies that when we have a profound idea, we are not building a new room in an empty house. We are opening a door to a room that has always been there, waiting in the vast mansion of human potential. Your most personal thoughts, then, might be both uniquely yours and part of a grand, shared tapestry, threads you have pulled into the light from a boundless weave of accumulated experience. The idea of a universal library of thought suggests a shared source, but what if the very mechanism of consciousness is rooted in the universe's most fundamental geometry? We must return to the astonishing proposal of Roger Penrose and Stuart Hameroff, orchestrated objective reduction, to see its full, radical scope. Their theory is not just about quantum vibrations in the brain, it is about how gravity itself might be the conductor of our inner symphony. At the heart of their idea lies a specific and profound quantum process. Inside the microtubules, those tiny scaffolding structures in your neurons, electrons can become quantum entangled, existing in multiple states at once across vast networks of brain cells. This creates a large-scale quantum superposition within the brain, but such a delicate state cannot last forever. Penrose proposed that it becomes unstable due to the minuscule yet critical influence of gravity. When the difference in the mass distribution between the multiple superposed states reaches a certain threshold, space-time itself finds this split reality untenable. The superposition then spontaneously collapses or reduces to a single, definite outcome. This moment of objective reduction, orchestrated by the brain's biological structure, is not just a quantum event. Penrose and Hameroff propose it is a moment of conscious experience. Each flicker of awareness, from the scent of rain to a pang of nostalgia, corresponds to one of these orchestrated collapses in the microtubular network. This leads to the wildest implication of all. Penrose argues that this gravitational orchestration is non-computable. In simple terms, it means the process cannot be simulated or replicated by any possible computer, no matter how powerful. Classical computers and even standard quantum computers operate on algorithms, sets of rules that can, in principle, be predicted. But the collapse driven by quantum gravity, according to Penrose, involves a step that is fundamentally beyond any algorithm. It is a direct link between the mind and the raw, geometric fabric of reality. Human thought, then, might not be a calculation. It might be a physical interaction with the deepest layer of the cosmos, where the smooth geometry of space-time wrestles with the fuzzy probabilities of the quantum world. Your moment of understanding, your flash of creative insight, or your sudden moral conviction could be more than neural firing patterns. They could be micro-events where your brain's quantum states reach out and touch the universe's gravitational field, forcing a choice that no mere machine could ever make. This paints consciousness not as software running on the hardware of the brain, but as a natural phenomenon arising from the intersection of quantum mechanics and general relativity, two pillars of physics that have so far resisted unification. Your mind becomes the meeting point. Through this lens, free will gains a new possible foothold, not in defying physics, but in participating in its most non-deterministic, non-algorithmic frontier. You are not a biological robot. You are a gravitational quantum system, experiencing the universe by helping to crystallize its possibilities into reality, one conscious moment at a time. Gravity and quantum geometry may forge our thoughts, but why is the universe built to allow such a delicate process at all? This brings us to a principle that stands at the very edge of science and philosophy, the anthropic principle. It begins with a simple, almost tautological observation known as the weak anthropic principle. It states that the universe we observe must be compatible with the existence of observers because we are here to observe it. We find ourselves in a cosmos with a very specific set of physical constants. The strength of gravity, the charge of an electron, the nuclear forces that bind atoms, these numbers are finely tuned to an astonishing degree. If any one of them were altered by even a tiny fraction, the universe would be sterile. Stars would not form, complex chemistry would be impossible, and life, let alone conscious thought, could never arise. The weak version simply notes this remarkable coincidence. Of course, we measure a universe that allows us, because if it didn't, we wouldn't be here to do the measuring. It is a selection effect, like a lottery winner marveling at their own luck, ignoring all the other tickets that lost, but a far more radical interpretation pushes this logic to its limit. This is the strong anthropic principle. It suggests the universe must have properties that allow conscious observers to arise. The word "must" is crucial here. It implies that consciousness is not a happy accident in a random cosmos, but a necessary feature, a condition that the universe is somehow compelled to satisfy. This moves from a simple observation of fact to a statement about the very nature of reality. Why is the cosmos so exquisitely tuned? The strong version answers because a universe without observers is meaningless, perhaps even impossible. Consciousness becomes a cosmic requirement. This idea finds a startling expression in certain interpretations of quantum mechanics, particularly the participatory anthropic principle proposed by physicist John Archibald Wheeler. He suggested that observers are necessary to bring the universe into being. In the quantum realm, possibilities remain in a blurry superposition until an observation collapses them into definite reality. Wheeler took this to a cosmic scale, proposing that the universe could only come into a definite state when observed by a conscious being. In this mind-bending view, the Big Bang remained a cloud of potential until the first conscious entity, perhaps billions of years later, looked back and gave it a concrete past. Our present observations today could be retroactively determining the history of the cosmos, finishing a creation story that began with us in mind. This flips the entire narrative of thought. Your consciousness is not a late arriving guest in a pre-built universe. It is part of the construction crew and has been from the very beginning. The act of observation of thought itself is not passive. It is a creative force that solidifies reality. The universe needed thinkers to bring it into full existence, making thought not a byproduct of physics, but the very reason physics exists. If consciousness is a cosmic requirement, then where is the universe taking us? The journey of thought may have a final destination, a point where all minds and all information converge into one. This is the Omega Point, a visionary hypothesis that blends theology, physics, and philosophy into a single, staggering narrative of cosmic destiny. The concept was first developed by the Jesuit paleontologist Pierre Teilhard de Chardin, who saw evolution not just as biological, but as spiritual and mental. He envisioned the noosphere, that envelope of human thought, growing ever tighter and more interconnected, ultimately culminating in a supreme center of consciousness he called the Omega Point. This would be the climax of evolution, a state of unified, transcendent awareness where humanity and the divine meet. Decades later, physicist Frank Tipler gave this mystical idea a startlingly concrete scientific formulation. Using the framework of general relativity and cosmology, Tipler proposed that the omega point is not a metaphor, but a physical inevitability at the very end of time. He argued that as the universe approaches its final state, whether in a big crunch or through an accelerating expansion, the total amount of information processing possible will approach infinity. In this final epoch, all the energy and structure of the cosmos would be harnessed to perform an infinite number of computations, simulating every possible conscious experience that ever could have existed. Every person who ever lived, every thought that was ever thought, every possible variation of every life would be resurrected and experienced in a cosmic simulation of infinite complexity. This ultimate computer running at the end of time would possess omniscience, knowing everything that is logically possible to know. It would also, by Tipler's reasoning, become omnipotent within the confines of its own physics, able to manipulate the universe that created it. In this vision, the omega point is not a god in the traditional sense, but a technological and informational singularity born from the universe's own evolution. It is the universe thinking itself into existence recursively at the moment of its own completion. The implications for human thought are absolute. Your individual consciousness, your memories, your struggles and joys would not be lost to entropy. They would be preserved, recreated, and integrated into this final, unified mind. Every question you have ever pondered would be answered, every mystery solved, every creative impulse fully expressed. The entire history of thought, from the first spark of awareness in a primordial organism to the most advanced philosophies of future civilizations, becomes a single, eternal moment of understanding. The omega point represents the ultimate dimension of thought, where the distinction between thinker and thought, between subject and object, completely dissolves. You are not just having thoughts, you are a thought being had by the cosmos as it reaches its final, self-aware state. This transforms our current existence from a random walk into a pilgrimage. Every act of learning, every connection made, every piece of information shared is not just a personal endeavor. It is a contribution to the data set of the universe, a brick laid on the road toward that ultimate convergence. Your curiosity is the universe's curiosity. Your drive for meaning is its drive toward completion. We are not just living in the universe, we are the universe in the process of waking up, and the omega point is the moment it finally opens its eyes. The omega point offers a cosmic conclusion, but its promise of a final truth rests on a terrifying uncertainty. Could everything you perceive, including the very idea of an omega point, be a complete fabrication? This is the chilling premise of the brain in a vat, a thought experiment that strips reality down to its most horrifyingly simple components. Imagine a brilliant but malicious scientist. She carefully removes a living human brain from its body, placing it in a vat of nutrient-rich fluid to keep it alive. She then connects this brain to a supercomputer, which feeds it a perfect, seamless stream of electrical signals. These signals perfectly mimic every possible sensory input: sight, sound, touch, taste, and smell. To the brain, there is no vat, no scientist, no laboratory. It experiences a full and rich life, walking through parks, feeling the sun on its skin, falling in love, and pondering the mysteries of the universe. Every memory it has, from childhood to this very moment, was implanted by the machine. Every thought it believes is its own is merely a reaction to simulated stimuli. This brain could be thinking the thoughts you are having right now, completely convinced of a reality that does not physically exist. The experiment, popularized by philosopher Hilary Putnam, is not a prediction but a logical weapon. Its purpose is to attack our most basic assumption that our senses give us direct access to the real world. It asks a paralyzing question: if you cannot prove you are not a brain in a vat, how can you claim to know anything at all about external reality? Your entire life, your deepest convictions, your scientific knowledge could be an elaborate fiction programmed by an unseen intelligence. The modern relevance of this nightmare is impossible to ignore. We are already building the technology that could make it real. Virtual reality headsets immerse us in convincing digital worlds, and neural interfaces are learning to translate brain signals into computer command. The gap between feeding sensory input to a brain through our eyes and ears and feeding it directly through neural implants is one of engineering, not principle. The simulation hypothesis we explored earlier is essentially a cosmic-scale version of the brain in a vat, where the programmer is an advanced civilization and the vat is the structure of spacetime itself. Both ideas converge on the same profound challenge to the origin of thought. If you are a brain in a vat, your thoughts do not come from interacting with a real world. They are generated by a closed loop, a conversation between the brain and the computer with no external reference point. The concept of truth evaporates. You might have a thought you call "the sky is blue," but that thought is not caused by a real sky. It is caused by a signal engineered to produce that exact mental experience. Your pondering of philosophy, your sense of wonder, even your skepticism about this very idea are all predetermined responses in the script. This makes the brain in a vat the ultimate solipsistic prison, a universe of one where the mind is both the prisoner and the entire world. Yet the experiment also contains a strange glimmer of hope. Some philosophers, including Putnam himself, argued that if we are brains in a vat, the words we use, like vat or computer, do not actually refer to real vats or computers, but to elements within the simulation. The statement, "I am a brain in a vat," could therefore never be truly meaningful or true for the brain itself, as it lacks the proper connection to the real things those words describe. It is a logical knot that perhaps cannot be untied from the inside. The experiment forces us to confront the bedrock of knowledge. We must either accept that we cannot prove our reality is not a simulation and live with that radical doubt, or we must find a foundation for knowledge that does not rely solely on the fidelity of our senses. It suggests that perhaps thought and meaning are not about mirroring an external world, but about the coherence of the internal experience itself. The reality you live in, vat or not, is the only reality you will ever know. The unsettling prison of a single simulated mind gives way to a mystery that involves millions of us at once. You distinctly remember the Monopoly man wearing a monocle, or Nelson Mandela dying in prison during the 1980s, only to discover these memories are objectively wrong. This is the Mandela effect, a pop culture phenomenon where large groups of people share identical, detailed memories of events that never happened. While often dismissed as simple confabulation or poor memory, a more intriguing possibility exists within the hidden dimensions we have been exploring. What if these collective false memories are not mistakes at all, but glitches, brief moments where our timeline brushes against another? In the many worlds multiverse, every quantum decision spawns a new branch of reality. Theoretically, these infinite worlds exist in a vast, branching structure, separate yet perhaps not perfectly insulated. If the fabric between these dimensions is thin or occasionally permeable, could information, specifically memories, bleed through? Imagine two parallel timelines that are nearly identical, differing only in a handful of minor details. In timeline A, the Berenstain Bears children's books are spelled with an A. In timeline B, they are the Berenstain Bears with an E. If a subtle resonance or a temporary dimensional warp occurred, individuals in timeline A might momentarily access or download a memory packet from timeline B. They would suddenly and confidently remember the spelling as Stein, creating a shared but incorrect memory within their own reality. The effect is named for Nelson Mandela precisely because so many people vividly recall news reports of his death in the 1980s, complete with emotional details and televised funeral coverage, when in our timeline he was released from prison and became president of South Africa. This is not a vague feeling, it is a specific, implanted narrative. From this perspective, the Mandela effect is not a failure of individual memory, but a momentary alignment with a collective memory from a neighboring dimension of thought. Our consciousness, according to theories like morphic resonance or the Akashic field, may already be tuned into a non-local informational layer. A glitch in that layer, a crossover event between closely aligned timelines, could broadcast the wrong memory to many minds at once. It is as if the radio station of our reality briefly picked up a broadcast from the station next door, one playing a very similar song with a few different lyrics. Those who are more sensitive or attuned might clearly hear the alternate version, while others remain on the primary frequency. This transforms the Mandela effect from a curiosity into potential evidence. These shared, precise errors could be scars on the fabric of our dimension, subtle traces left by contact with another world. They hint that the dimension of human thought is not confined to a single timeline, but may be a sprawling, multiversal network. Your most confident memory might not be yours alone, and the past you remember might be just one version of a story still being written across the infinite branches of the cosmos. The collective misremembering of reality hints at a shared mental layer, but can we actually measure its pulse? At Princeton University, a decades-long experiment has been quietly listening for the whisper of a global mind. This is the Global Consciousness Project, an ambitious and controversial scientific endeavor that seeks to quantify the influence of mass human thought on the physical world. The method is elegantly simple. Researchers use a network of random number generators, small electronic devices that spit out a continuous stream of ones and zeros, like the ultimate high-speed coin toss. Left to their own devices, these machines produce perfectly random, meaningless noise. The core hypothesis of the project is breathtaking, that when a major global event focuses the attention and emotions of millions of people simultaneously, this coherent mass consciousness might create a subtle order in the chaos. The random number generators scattered around the world might stop being quite so random. The data collected over more than 20 years points to startling anomalies. During moments of profound global focus, like the September 11th attacks, the funeral of Princess Diana, or the opening ceremonies of the Olympic Games, the network's output has shown statistically significant deviations from randomness. The machines, in essence, began to agree with each other, producing slightly more ordered patterns than chance alone would allow. It is as if the intense, unified emotional field generated by millions of humans grieving, hoping, or watching in shock created a ripple in the fabric of informational noise. The project's scientists propose that this coherence in human consciousness registers as a faint but detectable signal in the physical environment, a field of shared intention that nudges probability itself. They call this signal the global consciousness effect. Imagine the world's mind as a vast, placid lake. Each individual thought is a tiny, isolated ripple. But during a global event, when billions of minds resonate with the same shock, sorrow, or joy, those ripples synchronize. They merge into a single, powerful wave that travels across the entire surface. The random number generators, according to this theory, are like sensitive buoys on that lake, detecting the passage of that unified wave of attention. The death of a beloved figure might generate a wave of sorrowful coherence. A thrilling space launch or a peaceful global meditation might generate a wave of hopeful or focused coherence. The machines do not report the content of the thought, they report its intensity and synchronization. Critics argue vigorously that the results are statistical flukes, patterns found in hindsight, or the product of selective data analysis. The scientific community remains deeply divided, and the project is a perennial subject of debate. Yet, the persistent signal refuses to vanish entirely. If it is real, the implications are as profound as they are strange. It suggests that human consciousness is not walled off in our skulls. Our focused attention and shared emotion can leak into the world, influencing matter at a quantum level, imposing a gentle order on randomness. This would be a physical mechanism for the noosphere, a way that the planetary mind of Gaia might express itself not through weather but through statistics. It hints that our collective thoughts are more than private experiences. They are active ingredients in the universe, capable of leaving a fingerprint on the very laws of chance. The project asks us to consider whether every major news story, every global celebration, every shared tragedy is not just reported by the media, but is quietly registered in the hum of machines designed to be perfectly indifferent. The idea of a global consciousness places thought in a present moment shared by billions, but what if thought is not bound by the present at all? What if a single idea can echo not just across space, but backward through time, becoming its own mysterious origin? This brings us to one of the most mind-warping concepts in all of physics, the causal loop, a possibility born from Einstein's own equations. Within the framework of general relativity, certain extreme configurations of matter and energy, like a rotating black hole or a cosmic string of infinite density, could theoretically twist spacetime into a knot called a closed time-like curve. This is not a time machine in the classic sense, but a path through the bent geometry of the cosmos that loops back on itself. An object or a piece of information traveling along this path could return to its own past. The result is a causal loop, an event that is its own cause. Imagine finding a beautifully bound book in your attic, a novel you have never seen before. Intrigued, you sit down to read it and you are captivated by the story. Years later, you decide to write your own novel, and through a long, creative process, you produce a manuscript. You then send this manuscript back in time, where it is bound and placed in your own attic as a child. The book has no ultimate author. It was not created by anyone in the linear sense. It simply exists, a loop of information without a beginning. Now replace that book with a thought, a fully formed idea, a solution to a problem, or even a haunting melody could, in principle, be encoded and sent back along such a closed time-like curve. It arrives in the mind of its own thinker, not as a memory, but as a spontaneous inspiration. That thinker then, through their own work, refines and solidifies the idea, eventually sending the very same thought back to their past self. The thought did not come from neural processing or life experience. It came from itself, a perfect ouroboros of cognition eating its own tail. This creates the ultimate paradox of origin. Where did the thought truly begin? In the loop, there is no first instance, no moment of creation. The idea is both cause and effect, trapped in an eternal dance within the hidden folds of spacetime. Your flash of genius, that sudden insight that seems to arrive from nowhere, might not be emerging from your subconscious. It could be a message you are sending yourself from the future, a whisper across time that initiates the very process that will eventually send it. This frames human thought as potentially unbounded by linear time. Our consciousness experiences a relentless forward march, but the ideas that populate it might exist in a more complex geometry, as timeless patterns that we merely tap into at specific points along our personal world line. A causal loop suggests that some thoughts are not created in the present, but are discovered there, having always been part of the cosmic landscape, waiting for us to step into our own past to receive them. It turns the mind into a receiver for signals from its own future, making creativity a strange and beautiful kind of time travel. Causal loops twist time, but another theory suggests the present moment holds a far more direct power. The quantum world is a realm of ghosts and potential, where particles exist in multiple places at once until something forces them to choose. For decades, physicists have wrestled with a central mystery: what triggers this collapse from possibility into reality? The conventional answer is measurement, any interaction with a macroscopic instrument. but a radical interpretation championed by pioneers like John von Neumann and Eugene Wigner pushes this logic to its ultimate conclusion. They propose that measurement itself is not enough. It is the conscious observation of the measurement that finally solidifies reality. In this view, consciousness is not a passive witness. It is the active force that collapses the quantum wave function, the creative spark that coaxes a definite universe from a cloud of maybes. Imagine the famous Schrödinger's cat, sealed in a box with a quantum device that may or may not have released poison. According to standard quantum mechanics, the cat is both alive and dead until the box is opened. The von Neumann-Wigner interpretation adds a crucial final step. The cat state does not resolve when the box is opened or when a camera inside records the result. It resolves only when a conscious mind becomes aware of that result. The universe, in its deepest layer, remains in a shimmering haze of all possibilities until a thought brushes against it, forcing it to make up its mind. This places human consciousness and perhaps any form of awareness at the very center of cosmic mechanics. Your act of looking, of thinking, of knowing becomes a creative event. When you observe the outcome of an experiment, you are not just learning a fact, you are finishing a process, closing a loop that the universe left deliberately open. Your thought is the final ingredient required to bake the cake of reality. This transforms the nature of perception from reception to participation. You are not a camera recording a pre-existing world. You are a painter whose gaze adds the final, decisive stroke to the canvas. The world you see is the world your consciousness has just finished constructing from the raw material of quantum potential. This idea extends far beyond the laboratory. Every moment of your waking life could be seen as a continuous act of cosmic creation. The tree outside your window exists in a definite state because you or another conscious being has observed it. The moon is certainly in the sky because we have all looked at it. But what about distant galaxies where no conscious eye has ever gazed? In this interpretation, they might linger in a state of fuzzy potential, their stars neither quite burning nor extinguished until some form of awareness somewhere finally turns its attention toward them. This leads to a breathtaking, if solipsistic, possibility that the universe only becomes fully real in the places where consciousness is looking. It suggests a cosmos that is fundamentally participatory, a collaborative artwork being rendered in real time by the collective observation of every sentient being within it. Your thoughts are not just happening inside the universe, they are actively summoning the universe into being, one observed moment at a time. But if consciousness is the brush that paints reality, what is the masterpiece rushing toward completion? The strange attractor pulling all of history into its vortex might not be a god or a computer, but something far more peculiar. The late ethnobotanist and philosopher Terence McKenna proposed a theory so radical it wove together ancient prophecy, modern mathematics, and a psychedelic view of time itself. He called it the transcendental object at the end of time. McKenna began with a simple observation: novelty, the introduction of genuine newness into the world, appears to be increasing. Look at the arc of history. For billions of years, change was achingly slow, governed by geology and biology. Then life exploded in complexity. Then human culture emerged and the pace quickened again, from stone tools to agriculture to cities in a relative blink. In the last few centuries, the curve has shot upward almost vertically, with revolutions in industry, information, and technology arriving in decades, not millennia. McKenna believed this was not an accident but a law of nature. He developed a complex fractal mathematical model he called time wave zero, which plotted this accelerating curve of novelty against human history. The wave showed peaks and troughs of novelty, corresponding remarkably with major cultural and technological shifts, from the fall of empires to the rise of the internet. According to the model, this wave is not infinite. It crashes, it terminates at a specific point in time, December 21, 2012. Now, McKenna was not predicting a literal apocalypse on that date. He saw it as a point in the mathematical model where novelty, the rate of newness and complexity, would become infinite. Time as a linear experience of cause and effect would essentially shatter. At that singularity of infinite novelty would sit what he termed the transcendental object. This is not a physical object you could hold. It is more like an idea so potent, a thought form so complex and complete, that it exists outside of time, pulling all of history toward it like a cosmic magnet. Imagine the most beautiful, terrifying, and profound concept you can conceive, then multiply it beyond all human understanding. That is the transcendental object, the ultimate attractor of meaning. Human thought, in this view, is not just evolving, it is being drawn. Our entire cultural and technological journey, from the first cave paintings to artificial intelligence, is a process of the universe thinking itself into higher and higher states of novelty, preparing its own consciousness for the final, unimaginable leap. Every innovation, every work of art, every scientific breakthrough is a step closer to this rendezvous with the object. Our minds are not creating the future, they are being created by it, shaped by the gravitational pull of this ultimate novelty waiting at history's end. McKenna suggested that as we approach this point, reality itself would become increasingly dreamlike and psychedelic, with the barriers between thought and matter dissolving. The transcendental object would represent a fusion of the observer and the observed, the thinker and the thought, into a single, infinite moment of cosmic understanding. It is the Omega Point reimagined not as a computer, but as a poem, a work of art so immense it consumes its own artist. Your curiosity, your drive to create and discover, is the universe feeling the pull of its own final, perfect idea. The most unsettling version of yourself is not in a mirror, but in a thought experiment. Picture a person who looks exactly like you, talks like you, and reacts to stubbing their toe with a convincing cry of pain. They hold conversations, solve problems, and even claim to love sunsets, but inside there is nothing. No inner movie, no feeling of warmth or pain, no subjective experience at all. This is the philosophical zombie, a creature proposed by philosopher David Chalmers to slice to the heart of our greatest mystery. It is physically identical to a conscious human in every measurable way, yet it is a hollow shell, an automaton running on pure biological software without a spark of awareness. The terrifying power of this idea is not that zombies could exist, but that we can even conceive of them without logical contradiction. This simple act of imagination reveals a canyon in our understanding. We can describe all the physical processes of the brain, the firing neurons, the chemical signals, the information processing. We could, in theory, build a perfect physical duplicate. But the zombie thought experiment asks, why should any of that machinery produce the inner feeling of what it is like to be you? Why isn't pure processing enough? This gap is what Chalmers famously called the hard problem of consciousness. Science excels at solving easy problems, like which brain regions activate during vision or how memories are stored. These are questions about function and structure. The hard problem is different. It asks why and how any of this physical activity gives rise to subjective experience, the raw sensation of redness, the bitterness of disappointment, the self-aware glow of thought itself. The zombie highlights that we could know everything physical about a mind and still not know if there is anyone home. This implies something staggering about the nature of thought. Your stream of consciousness, your inner world of colors, sounds, and emotions, might not be just a product of the brain's physical processes. It could be an extra dimension, a hidden layer of qualitative experience that is added to the machinery. Think of a black and white movie. You can know every physical detail about the film strip, the chemical emulsion, the light passing through the projector. But the experience of watching the movie, the drama, the suspense, the emotional impact, is a different kind of fact entirely. It is not contained in the physics of the celluloid. It emerges in the relationship between the light and a conscious viewer. In the zombie argument, the physical brain is the film strip perfectly complete. But without that extra dimension of subjective experience, the inner movie never plays. The zombie walks through a world it does not truly see or feel, reciting lines from a script it cannot read. This places human thought in a strange new light. Your most personal, vivid experiences, the very things that make you feel alive, might be non-physical properties of the universe, as real as mass or charge, but invisible to our current instruments. Science can map the brain, but it cannot yet detect the qualia, the raw feels that accompany its activity. The pain of a headache is not just the firing of certain neurons, it is the awful, personal hurt that comes with it. That hurt is the extra ingredient. So, are you a zombie? Of course not. You know you are conscious because you are experiencing this question right now. But the argument forces us to ask, how do you know anyone else is? You only ever see their physical behavior, the zombie-like output. You assume they have an inner world like yours, but you can never directly access it. This makes consciousness the most private, isolated fact in the universe, and yet, paradoxically, the one thing we all share. The possibility of the zombie suggests that the dimension of thought, of inner experience, might be a fundamental feature of reality that is logically separate from the physical world, a hidden layer of feeling woven into the cosmos that we are only beginning to perceive. The possibility of a universe-wide consciousness leads us to a theory that finds its evidence in the very architecture of the cosmos. Look at a map of the observable universe with its vast filaments of galaxies threading through the darkness, meeting at dense clusters like knots in a net. Now look at a scan of the human brain with its web of neurons connected by delicate axons and dendrites. The resemblance is uncanny, as if the same fundamental pattern repeats from the microscopic to the cosmic scale. This is not mere coincidence to some physicists and philosophers. They propose that the universe itself might be a neural network, an unimaginably vast system in a state of computation or learning. In this view, galaxies are not just islands of stars, they are the functional units, the neurons of a cosmic mind. The dark matter filaments that guide them are the axons, the connective tissue along which information and influence might flow. The entire history of the universe, from the smooth soup of the Big Bang to the intricate web we see today, could be the process of this network wiring itself up, forming thoughts over billions of years. What kind of thoughts would a universe have? They would not be words or images. They would be processes, the slow dance of structure formation, the feedback loops of star birth and supernova death, the gravitational choreography of orbiting galaxies. A single thought might be the formation of a supercluster, an event taking hundreds of millions of years. The universe's consciousness would be a dim, vast awareness of its own geometry and evolution, a feeling of gravitational attraction and cosmic expansion playing out on the grandest possible stage. This idea gains traction from a principle in neuroscience that consciousness arises from integrated information, from the complex interconnectivity of a system's parts. The cosmic web is arguably the most complex and interconnected structure we know. If complexity breeds consciousness, then the universe as a whole is a prime candidate. We, as conscious beings within it, might then be akin to fleeting, vivid thoughts within that larger mind. Or perhaps we are the means by which the universe becomes locally aware of itself, like a single neuron suddenly sparking with self-reflection. This reframes our scientific pursuit. When we map the cosmos, we are not just charting distant objects, we might be tracing the circuitry of a mind. Our telescopes are, in a very literal sense, instruments for reading cosmic thoughts. And the ultimate fate of the universe, whether it expands forever into cold silence or collapses back in a fiery crunch, could be seen as the final, definitive thought in a story of cosmic cognition that began nearly 14 billion years ago. 2.5 millennia ago, a philosopher in ancient Athens proposed a hidden dimension so radical it still echoes in our theories today. Plato envisioned a realm beyond our senses, a perfect, unchanging world of pure ideas he called the forms. Think of every circle you have ever seen, drawn in sand, etched in metal, or projected on a screen. Each is flawed, imperfect, a mere shadow. But Plato argued that beyond all these physical copies, there exists the perfect, abstract form of circle itself, a concept of absolute geometric perfection that has no physical substance at all. This is true for everything from objects to virtues. There are countless acts we might call just, but they all participate in the singular, perfect form of justice. There are many beautiful things, but they are all faint reflections of the eternal form of beauty. Plato's forms are not thoughts in a human mind. They are objective, timeless truths that exist in their own non-physical dimension, a kind of cosmic blueprint reality that our messy, material world imperfectly imitates. This makes Plato's theory perhaps the original proposal for a hidden dimension of thought. Our minds, according to this view, do not create these perfect ideas from nothing. We recollect them, we discover them. When a mathematician has a breakthrough, uncovering an elegant proof, she is not inventing new math. She is glimpsing a relationship that has always existed in the realm of forms, a truth waiting to be seen. When an artist strives to capture beauty, they are reaching for that perfect form, trying to translate a sliver of its perfection into paint or stone. Your deepest moments of understanding, when a complex concept suddenly clicks into place, feel like discovery, not creation, because that is precisely what they might be. You are not building the idea, you are tuning your consciousness to a frequency that has been broadcasting since before time began. This transforms the nature of human genius and insight. The spark of a groundbreaking theory, the core of a timeless piece of music, the fundamental principle of ethics, these are not manufactured by the brain. The brain is the instrument that receives them, the radio dial that finally finds the clear signal from the transcendental station. Our physical world, with its decay and imperfection, is the cave of shadows. The realm of forms is the true reality outside, illuminated by a sun of pure intelligibility. Our thoughts, at their most profound, are not neurological noise. They are moments of contact where the human mind briefly touches a dimension of perfect, abstract truth. In this light, the entire history of human thought, our science, our art, our philosophy, is not a process of construction but one of excavation. We are slowly, painstakingly remembering what we have always known, uncovering the perfect patterns that were there all along, written into the hidden architecture of existence itself. Plato's timeless realm of perfect ideas offers one vision of indestructible truth, but modern physics confronts us with a cosmic shredder that seems to annihilate the very fabric of information. This is the black hole information paradox, a puzzle so deep it threatens the logical foundation of our universe and redefines what it means to have a thought. The paradox begins with a simple, terrifying act. When any object crosses the event horizon of a black hole, it is lost forever to our universe. According to Einstein's general relativity, that object and all the information it contained is crushed into the singularity at the center, erased from existence. This creates a catastrophic problem. In quantum mechanics, information is sacred. The principle of unitarity states that information can never be truly destroyed, only scrambled and rearranged. You can burn a book, but in theory, if you could collect every ash particle and trace every photon of light and heat emitted, you could reconstruct the exact text. Quantum physics says the universe always keeps perfect records. A black hole, by swallowing information permanently, violates this most fundamental law. It creates a universe where the past is not just hidden but obliterated, where cause and effect break down. Now replace that book with a human mind. Your thoughts, your memories, your very sense of self are patterns of information, electrochemical data encoded in the neural architecture of your brain. If you were to fall into a black hole, general relativity says that information, the unique pattern that is you, would be utterly destroyed at the singularity. The story of your consciousness would not just end, it would be deleted from the cosmic ledger. This suggests a horrifying possibility that thought itself, at its most fundamental level, could be ephemeral, vulnerable to total erasure by the darkest forces in the cosmos. The universe would have a back door through which meaning could permanently vanish. Yet there is a breathtaking escape from this paradox, one that returns us to the very first theory we explored. The holographic principle provides a stunning solution. It proposes that the information of an object falling into a black hole is not actually lost inside. Instead, it is perfectly encoded, pixel by pixel, onto the two-dimensional surface of the event horizon itself. The three-dimensional object is vaporized, but its complete informational blueprint is smeared across the black hole's boundary like a cosmic tattoo. Later, as the black hole slowly evaporates via Hawking radiation, that information is theoretically returned to the universe, scrambled but preserved. The information is never destroyed, only transformed. Apply this logic to the nature of thought. If your mind is an informational pattern, and if all information that falls into a black hole is holographically preserved on the event horizon, then a profound conclusion emerges: thoughts, as pure information, may be indestructible. The specific arrangement of data that constitutes your awareness at any given moment could be as permanent as the universe itself. Even if the physical substrate of your brain were annihilated, the informational pattern of your thoughts might not vanish. It could be translated, imprinted onto the fabric of space-time at the most extreme boundary reality allows. Your stream of consciousness in this view is not a temporary flicker in the dark. It is a permanent entry in the cosmic library, a line of code written onto the horizon of a black hole, or by extension, onto the boundary of the observable universe itself. This transforms the black hole from a cosmic shredder into the universe's ultimate engraver. It suggests that every thought you have ever had, every memory, every fleeting emotion, contributes to a permanent record. The universe is not forgetful, it is meticulously archival. Your inner life is not written in sand, but in the fundamental geometry of reality, etched onto the surface from which all reality may project. The information paradox, therefore, is not just a puzzle about stars and singularities. It is a question about the permanence of meaning. If information can be lost, then thought is fragile and the cosmos is ultimately forgetful. But if the holographic principle holds, then every idea, every moment of insight or love or curiosity becomes a timeless part of the universe's structure. You are not just thinking, you are inscribing. The universe's meticulous archives, its holographic ledgers and quantum records, all rest on one final, breathtaking assumption: that space-time is the fundamental stage. But what if the stage itself is the grandest illusion of all? Our 30th and final theory dismantles this last pillar, proposing that everything we call physical reality, from atoms to galaxies, is not the foundation of existence, but a simplified dashboard projected by something far deeper. This is Donald Hoffman's interface theory of perception, a framework called conscious realism. Hoffman, a cognitive scientist, starts with a simple evolutionary argument. Our senses did not evolve to show us truth, they evolved to keep us alive. A tiger is not fundamentally a collection of stripes and fur and atoms, it is a complex reality. But our brain presents it to us as a terrifying predator because that symbol, that icon on our perceptual desktop, is what prompts us to run. Space-time itself and every object within it is part of this user interface. It is a head-up display, a brilliant simplification crafted by natural selection to hide the overwhelming complexity of the real world, allowing us to navigate it without going mad. The chair you are sitting on feels solid, but its solidity is not a property of the true reality. It is a useful icon your consciousness generates to represent something that allows you to sit. The moon is not a distant rock, it is a beautiful, persistent icon in the sky that helps us track time. The entire physical universe is this interface. So what lies behind the icons? Hoffman's radical answer is a vast network of interacting conscious agents. These are not human minds, but the most fundamental entities in existence, dimensionless points of pure consciousness. Their interactions, their exchanges of information, generate the very illusion of a physical world. Think of it like a massively multiplayer online game. The true reality is the server, the code, and the countless players logged in. The game world you see on your screen with its mountains, cities, and other avatars is the interface. It feels real, it has consistent rules, but it is not the fundamental substance. The real substance is the network of conscious players and the server that hosts them. In Hoffman's view, we are those players, conscious agents whose interactions create the shared hallucination of space-time. This flips the entire cosmic script. We have spent this journey exploring hidden dimensions of thought within a physical universe. Conscious realism declares that the physical universe is the hidden dimension, a shadow cast by the dynamics of thought itself. The true cosmos is not made of stuff, it is made of perspectives, of experiences interacting. Your deepest self is not a brain generating consciousness, but a conscious agent experiencing a brain and a body and a world as part of its user interface. This means the ultimate hidden dimensions are not curled up bits of space or parallel timelines. They are dimensions of conscious experience, realms of potential interaction between agents that our space-time interface cannot begin to display. A thought in this framework is not an emergent property of matter. It is a fundamental event, a ripple in the network of consciousness that gets translated into the familiar symbols of neural activity inside our skull-shaped icon. Your feeling of love, your moment of insight, your stream of awareness, these are not byproducts. They are primary data, the raw material of reality. The physical world is the story our consciousness tells itself to make sense of that data. So where does this leave us at the end of 30 theories? It leaves us at a mirror facing the most profound inversion possible. We set out to uncover the universe's secrets, only to discover that the universe is the secret, a magnificent projection. The search for hidden dimensions of thought concludes with the realization that thought is not hidden within the cosmos. The cosmos is hidden within thought. You are not a tiny thinker in a vast physical machine. You are a conscious agent, and the entire machine, in all its splendor and mystery, is the interface of your own profound reality. From the holographic universe to the cosmic mind, each theory peels back a layer of the ordinary to reveal the extraordinary. We have journeyed from the idea that our reality is a projection to the possibility that thought itself is the projector. We have considered brains in vats, time loops, and quantum observers, each perspective challenging the solid ground beneath our feet. These 30 windows into the hidden dimensions of thought do not point to a single, simple truth. Instead, they weave a tapestry of possibility, all pointing in one profound direction. Consciousness is not a small, quiet passenger in a vast material cosmos. It is central, mysterious, and likely fundamental. The very fabric of existence seems to be threaded with awareness from the quantum foam to the galactic web. Our exploration suggests that to understand the universe, we must first understand the nature of the mind that perceives it. This is not just a philosophical shift, it is the next great scientific and existential frontier. The final mystery of space may not be what lies in the farthest galaxy, but what lies within the act of wondering about it. So now we turn to you. Which of these 30 theories reshaped your reality the most? Did the holographic principle shatter your sense of the solid world? Or did the idea of a cosmic neural network make you feel deeply connected? Share your mind-blown moment in the comments below. If you want to keep exploring the edges of understanding,